Hi viewers, I am Divya Naisal, Assistant Professor, EEE Department, Arunachala College of Engineering for Women. Today, I will discuss the topic from the subject High Voltage Direct Current Transmission. Unit 1 DC Power Transmission Technology. In this video, we will discuss about the topic Introduction, Comparison of AC and DC Transmission, Application of DC Transmission, Description of DC Transmission. What do you mean by DC and AC transmission? DC transmission means it requires only two conductors compared to AC transmission. In DC transmission, there is no skin effect. Skin effect means sum of AC current around the conductor, it increases the losses. Third point, a DC line has less corona loss and reduced interference. AC transmission means the power can be generated at high voltages. The maintenance of substation is easy and cheaper. Advantages of HVDC transmission: full control over power transmitted, the ability to enhance transient and dynamic stability in associated AC network, fast control to limit fault current in DC lines, reduce the transmission lines. So, reduce the transmission lines means number of transmission lines and length of the transmission line should be reduced. Interconnection of system operating at different frequency. Some of the disadvantages of HVDC transmission: inability to use transformer to change voltage level, high cost of converter equipment, generation of harmonics with require AC and DC filters, adding to the cost of converter station, complexity of control. Next one, distinguish between AC and DC transmission. In DC transmission, it requires only 3 conductors, but DC transmission requires only 2 conductors. Skin effect is present in AC. The skin effect produces some of the current increases nearer to the conductor. In DC transmission, there is no skin effect. Third point, more corona loss. Corona loss means nearer to the conductor, some ionization produced. This causes more power loss. In DC transmission, less corona loss. Fourth one, stability problem occur. In DC transmission, there is no stability problem. In AC transmission, conductor cost is high because 3 conductors are used. In DC transmission, only 2 conductors are used. So, conductor cost is less. Sixth point, power loss due to skin effect. In DC transmission, less power loss. Seventh point, power loss due to Ferranti effect is increases in AC transmission, but DC transmission there is no Ferranti effect. Eighth one, it needs a reactive power compensation. So, some of the fact controllers are used, it increases the cost. In DC transmission, no reactive power compensation. Ninth one, voltage control is difficult. In DC transmission, voltage control is easy. Next one, some comparison apart from the previous slide. It is based on first one, economics of power transmission, second one, technical performance, third one, reliability. Economics of power transmission, it includes the operational cost and investment cost. Investment include cost of transmission towers, conductors, insulators and terminal equipment. In operational cost include cost of the losses. So, in DC transmission, economic point of view, DC transmission is the best one compared to AC transmission. Second one, technical performance. Technical performance includes stability limit, voltage control, line compensation, problem of AC interconnection. Last one, ground impedance. Stability limit means the power transfer in AC line is depend on the angle difference between the voltage phasor at the two end. For a given power level, this angle increases with distance. So, number of transmission lines increases, the angle also increases. So, in DC transmission, stability limit which is used to reduces the number of transmission lines. Next one, voltage control. Voltage control in AC line is complicated compared to DC transmission. So, in voltage control, DC transmission is possible. Third one, line compensation. In compensation, reactive power compensation technique used in AC transmission. So, some of the fact controllers are used. So, fact controllers used means cost of the overall section will be increased. In this point, DC transmission is best one. Next one, problem of AC interconnection. When two power systems are connected through AC ties, the automatic generation control of both systems have to be coordinated using tie line power and frequency signal. In this AC interconnection, the presence of large power oscillation which can lead to frequent tripping. It increases the fault level in AC transmission. So, technical performance in problem associated with AC interconnection is DC transmission is best one. Next point is ground impedance. In AC transmission, the existence of ground current cannot be permitted in steady state due to high magnitude of ground impedance, which will not only affect efficient power transfer but also result in telephone interference. So, in this ground impedance, DC transmission is best one compared to AC transmission. Third one is reliability. Reliability of a DC transmission is good compared to AC system. In reliability includes, it measures overall system reliability. First one, energy availability. Energy availability which is equal to 100 into 1 minus equivalent outage time divided by total time. Next, transient reliability. Transient reliability equal to 100 into number of times HVDC system performed as designed divided by number of recordable fault. Then next one, application of DC transmission. DC transmission is applied for long distance bulk power transmission, underground or underwater cable, asynchronous interconnection of AC system operating at different frequencies, control and stabilization of power flows in AC ties and integrated power system. Next heading is description of DC transmission system. In description of DC transmission system consists of different types of link. First one, monopolar link. Second one, bipolar link. Third one, homopolar link. Monopolar link means it has only one conductors which have negative polarity and uses earth or sea as a next point. That means earth potential act as a positive polarity. In monopolar link, metallic return is also used. In this link, two converters are placed at end of each pole. Earthing pole is done by earth electrode placed about 15 to 55 km away from the respective terminal station. This is the diagram for monopolar link. Disadvantages of monopolar link means The link has several disadvantages because it uses earth as return path. Monopolar link is not much in use nowadays. Next link is bipolar link. Bipolar has two conductors, one positive and the other negative with respect to earth. The midpoint of the converter at each terminal station are earthed via electrode lines. The voltage between the conductors is equal to 2 times the voltage between either of the two conductors and grounds. Since one conductor is positive polarity with respect to earth and other one is negative with respect to earth. In bipolar link, when one pole goes out of operation, the system may be changed to the monopolar mode with the ground returns. Thus, the economic point of view, monopolar link is commonly used, cheap and best. This is the diagram for bipolar link. Next one is homopolar link. It has two or more conductors are used with the same polarity, mainly used as a negative polarity, and always operate with earth or metallic return. In homopolar link, poles are operated in parallel, which reduces the insulation cost. So, this system is not used. This is the diagram for homopolar link. Okay, thank you students.